Okay, so I guess we are on time. So let me kick this off. Good morning, good evening, everyone. It's great to see you all here for our latest Sitecore user group meetup gathering in Jaipur. So today we are excited and honored to have Sergey with us to present about building advanced RAG systems with Sitecore products and putting AI assistant in production. So let me tell something about Sergey. He's a five-time Sitecore technology MVP and working as a senior solution architect at Brimit. So I would like to hand over this session to him, and you may begin your presentation.
Hello, everyone. So nice to see you. So I hope today you will enjoy with my presentation. And today we talk about advanced retrieval-augmented generation systems with Sitecore products. How to build virtual assistants or chatbots for your Sitecore websites. How to choose correct solution architecture for your websites and how to put it all in the production. But before we start, let me once again introduce myself. So my name is Sergey Baranov. I'm Sitecore solution architect at Brimit with about 11 years of experience with Sitecore development. Also, I'm 5 times Sitecore technology MVP and Sitecore CDP, personalized and XMCloud certified developer. And also, I'm a machine learning engineer, so I hope I'm the right person who can tell you how to implement and use some machine learning and artificial intelligence solutions in Sitecore products. So here you can see my today agenda. First, we have a small introduction to virtual assistants. Next, we review classic or naive retrieval augmented generation approach. Then we talk about advanced track, about different optimization techniques that can highly improve the quality of chatbot answers. Also, we talk about how to personalize answers and so on. Next, we have a topic about choosing solution architecture, some frameworks and tools, how to connect it all together with Sitecore products and compare all of them and choose the best one solution for production. And finally, of course, I will show you some demos. And in the end of my presentation, I will be glad to answer your questions. And let's start. So it's no secret that artificial intelligence is growing very, very fast. New AI models and tools come out about every day. Many websites now have virtual assistants or chatbots. And when we want to make a chatbot for our own website, we can face a problem of choosing some optimal LLMs, optimal architecture, frameworks, tools, etc. And my goal today is to show you how these agents are implemented, how to choose correct architecture, and how they integrate with Sitecore products. And let's start with a list of requirements for our chatbot. First of all, it must be an assistant who has access to the content of our website. It can answer questions and make some recommendations based on our own content. It should be also support voice and image inputs, for example, for easy usage in the mobile applications. Next, it should be multilingual, understand multiple languages, but it's not a problem for artificial intelligence. Next is no hallucination. And this is the biggest problem of virtual assistants nowadays, and we must avoid any kind of hallucinations. Next is chat and user sessions. Each individual user should have their own session and their own chat history. Next feature is access to users' data. For example, if chatbot have access to user data, then it can make responses and answers more personalized. For example, if our chatbot can hit Sitecore CDP, extract some data about user orders, about user sessions, segments, etc., it can personalize the answer very high. Next is cross-platform. We need to have virtual assistants in both website and mobile applications. Even we have experience with implementing chatbots for social media like WhatsApp, Telegram, etc., or Slack bot. Next point is analytical monitoring tools. Very often our clients ask about the ability to analyze and monitor all requests to chatbots, and monitor cost of requests, monitor users, their sessions, and so on. Next is performance and cost. Of course, we must take care of the performance and cost of the chatbot and offer different architecture options to our clients. And finally, our solution should be scalable. For example, if a customer wants to add some new features in the future or extend somehow the chatbot, it should not be a very complicated process. So here you can see a list of features, how our virtual assistants can communicate with Sitecore products. And first option is Sitecore Personalize. And I will tell you a real-life example. Since AI chatbots are relatively new, and most likely that your client doesn't have experience with it. And before running the chatbot in production, the client wants to test it, for example, on a small part of website audience, then extrapolate these results, and just to understand whether the integration of chatbot it worth the money spent, what is the profit, etc. The next point is Sitecore CDP. We want to personalize chatbot answers. To do it, chatbot should be able to get information from Sitecore CDP, such as user sessions, events, abandoned products, and so on. OrderCloud is about the same. Chatbot can access to user orders, and we need ability to communicate our virtual assistants with OrderCloud. Next is Sitecore Send. We want our chatbot to be able to add a user to subscription list, to campaigns, enroll any campaigns, or just send a regular email to particular user. Next is Sitecore Search. We want to be able to make a direct request to Sitecore Search to retrieve some relevant information and create an answer based on this relevant content. And the next option is Sitecore Connect. For example, if you want to start any automation in Sitecore Connect, we can ask our chatbot to trigger some webhook in Sitecore Connect. And let's start with the simplest one solution where we make a direct request from the backend of our website to the LLM. This is how many content generation modules works. I think you have seen a lot of demos with Sitecore products where you just send a direct request from Sitecore to LLM, for example, to OpenAI, about content generation, about translation, or something like this, and use it for your some desired solutions. But of course, with this approach, you are not able to do anything more complicated than content generation or translation. And let's have a look at some limitation of LLMs. All of LLMs have limitations, even including reasoning models like DeepSeek or Suri, or etc. But we will look only at just 3 of them that are most significant for virtual assistants and for retrieval-augmented generation in general. Of course, the first significant limitation of LLM is limited knowledge. If you ask something that is out of training data of LLM, then at best you will get a honest answer like, sorry guy, I don't know, I don't have this information. But it's more likely that LLM will just make up something and answer you that looks like the truth. And here is the second. The problem of LLMs is hallucination. And this is actually the biggest problem when you're dealing with LLM, because no one wants their client to get false information. And by the way, the retrieval-augmented generation has hallucination problem even stronger, because sometimes LLM has some basic knowledge about your website, about your products, but not relevant to the user's query. And LLM thinks that information that it has is enough and try to produce the answer based only on its own limited knowledge. And of course, LLM is not able to personalize the answer because it doesn't have any information about end user. And let's have a look at the classic or naive retrieval-augmented generation. RAG is abbreviation of Retrieval-Augmented Generation. In simple words, it's just a technique for improving the accuracy of generative models by providing information from some external data sources. For example, for content of your website. And if you look in our initial diagram, it will simply looks like a new node data source on the right side. That is actually content of your website. The operation logic of naive RAG is still quite simple. A user submit requests to the LLM. LLM just forward this user question to the data source and get some relevant information related to user query. And next, LLM adds this relevant information to the user's question and generate an answer. So here is an example of naive RAG implementation with Sitecore search. Now, this is just a screenshot of one of LLM orchestration tool that is responsible for configuring virtual agents. We will look at them a little bit later. For now, it's just to give you an idea how it works. The main node of any pipeline of agents is a tool agent. It's connected to one of the LLM of your choice. For example, we use in this screenshot chat OpenAI with any model like for or mini, but you can substitute with any model that you need. For example, with Azure, Google, etc. And on the right side, we can connect any tools that we want our agent to use. And in this specific case, we can just connect Sitecore Search as a tool for retrieving information. And this is the simplest one configuration. For tool agent, you need to configure some system instruction, and one of instruction is when and how to use Sitecore Search tool. In our case, answer this question based on your own knowledge and information that you retrieve from Sitecore Search tool. And the last thing we need to do is configure connection to Sitecore Search. We just need provide credentials and point URL where our tool agent will hit. And finally, configure some parameters to the Sitecore Search request. So as you can see, we just forward the question of user as a key phrase parameter, asking about 10 more relevant results. And of course, additionally, if your virtual agents is rendered on the website that has installed Sitecore Search or Sitecore Discover, we can easily extract user identifier of the Sitecore Search and pass it as additional parameters to make response more relevant. And of course, this is not ideal solution because Sitecore Search is not designed as a semantic search engine, but for slightly different processes. But some insights right now, Sitecore works with integration of vector search in Sitecore Search, and in future, maybe in a few months, we will see a new updated version of Sitecore Search, and this kind of implementation will be enough. And now we are going to talk about advanced RAG. Advanced RAG doesn't have a clear definition. It's just a set of some optimization techniques and approach that help us to improve naive RAG significantly. In our initial diagram, we have a new node. It's named vector store. It's not advanced RAG yet. Naive RAG also work this way, but this is the bare minimum necessary for for already really good search for relevant information. I hope all of you know what is vector store. I will not tell you about them in detail. Vector store is just a data stores that enables indexing and retrieving information based on a vector representation of your data, and is used for semantic and similarity search. To make it easier to understand what we are talking about, let's take some website on which I will show everything as an example. So we have a website that sells perfume, and the first task for our assistants is to give information about some particular products or to be able to recommend some relevant perfume to user questions. So the next part of my presentation will be more technically and maybe boring. So if you're not a developer or just get bored, you can scan this QR code and try to chat with our virtual assistants in live. And let's start with the advanced RAG techniques. So all of these techniques can be divided into 4 different layers. First is indexing optimization, second is query optimization, third is retrieval optimizations, and post-retrieval. And let's start with the indexing optimizations. And there are 2 different techniques: is pre-process the data before indexing and chunking strategies. So information about our perfume of the website about our products, it's stored in the OrderCloud, Content Hub, and XM Cloud. So what we need to do, we need to merge all of information from these 3 systems and pass this data as a data source to the vector store. But before passing the data to vector store, we need to split all of our products in the chunks. And how to choose a correct chunk strategy? We have obviously JSON array of products, and the best idea is just to split and chunks as a JSON with one single product, product A, product B, product C, and so on. But there are different techniques for chunking your data, such as splitting your data in equal size chunks with some overlaps and so on. But for use cases like this, where you need ability to answer about some specific product, the best idea is store a product in a separate chunk. And now let's have a look to the second example of using the virtual assistant. Order manager of our website have a specific application where they can track and monitor all of orders, switch between different countries, between point of sales, and see some statistical information and monitor all of orders. And the second task for our virtual assistants is to analyze orders from a specific point of sale and provide some insights. How it looks like. So we choose one order or one separate point of sales, click give me please store insight. And as you can see, virtual assistants provide some insights like top selling products, alert for restocking products, analyze pending orders, shipping information, return analysis, fraud detection, suggestion, and so on. And let's have a look how we need to chunk our data for this use case. All of necessary data about our products, about our orders is stored in OrderCloud. But we are not able just to take all of orders, for example, for a month and pass this big amount of data directly to the LLM because it simply would not fit in the context window of the LLM. And of course, it's also not any sense in saving the separate order to a separate chunk, as we did in the previous example, because in the result, we need some aggregated and summarized information. And how to do it? And for this case, we can group all of our orders, but some specific criteria, such as order time, order status, delivery timing days, and so on, and store only summary aggregated information. And this will, first of all, reduce the size of data that we need to store. And additionally, it will be much easier to LLM to analyze it, to retrieve it and analyze it. And so just to summarize, for each specific use case, you need to chunk your information into semantically logical units that are necessary for your specific task. You don't index everything in a row because the more garbage you have in your data, the harder it will be for LLM to extract only useful information and to analyze it. And let's look at the second point, what kind of optimizations we can do at the query level. So let's go back to our simplest example, where our agent simply makes a query to the search index of Sitecore search. One more time, as you can see, we don't have any pre-processing of the user question. We just forward it as a key phrase parameter. But in theory, a user could ask several things at once. For example, how much one product cost and whether there is any discount for product B. And it's clear that we need to somehow break this question into two different questions and rephrase it, such as question one, what's product A price? And the second, product B discount. But in fact, when we use some agents pipeline, they do it themselves out of the box. And this is another advantage of using some LLM orchestration workflow or any other software that has a link chain behind the scene. And let me show you how it works. If I ask, for example, I want to buy something similar to Miss Dior perfume, and what's the price of Madavi? There are two different questions in my request, but agent will simply split my question into two different questions to the search. So first one will be similar to Miss Dior perfume, and second one will be just Madavi. And so you can see it works out of the box. And this is also a good advantage of using some agent pipeline tools. Yeah. So the second query optimization is routing your query. For example, for one of our clients, we made a WhatsApp chatbot that, in addition to answering user questions about products, could also log in user into account by one-time password and help him with orders. For example, cancel orders, create new one orders, issue refund or product replacement, etc. And for such scenarios, you need to use multi-agents workflow or sequential agents, where every single agent is responsible only for its own task. And in these cases, you have a supervisor agent or conditional agent that is responsible for routing your query to the corresponding correct agent. So as you can see in this example, I have a conditional agent that analyzes a user query, and if user query related to adding product to cart, making order, and so on, it will navigate the query to the order agent. The next is about product recommendation, some information about products, and will navigate user to the consultant agent, and otherwise, as a fallback, we just navigate it to conversation agent. And this is example how complex multi-agent workflow looks like in real solutions. And this is a seamless low-code integration. Just imagine if you need to programmatically implement all of this and configure somehow. So the next point is retrieval. And frankly speaking, it's a responsibility of the vector store. And our job is just to choose the correct one, vector store. The most important thing is supporting of hybrid search. When the search is not only by semantic, but also a combination of vector search and text search. And the more you can control it, switch between different algorithms, the better. You can also see here excluding vector outliers. And if a vector store allows you to filter results with a small score value, it's also very good. So the last section is post-retrieval. And it's clear, for example, with prompt engineering, the more accurate you prompt, the more examples it has, the better results you will have. Just experiment with prompt engineering, and you can highly increase the results of answer of your virtual assistant. Re-ranking is supported by many vector stores out of the box. Otherwise, you can ask your tool agent, to re-rank retrieved documents. And the last one is LLM fine-tuning. It's just a possible options, but I don't recommend to use it for retrieval-augmented generations because you will spend a lot of time for fine-tuning. But if you have frequently up-to-date products, you need to train to fine-tune your model once again, and as a result, you will not increase the quality of your virtual agents. And sometimes the result after fine-tuning can be worse than before fine-tuning. Yeah. So I highly not recommend you to use it. For example, with prompt engineering, you can achieve much better results. Okay, that's all with theory part, and let's move on to the practice. So this will be architecture of our solution, of our application. So I will tell you right away that we have our own servers for hosting. So we choose the architecture based on that we have our own servers. And for example, if you host your Sitecore solution in Azure, it's easier to you to use a semantic search or Azure AI from Drive, for example, where you have everything in one place at once. Of course, it costs money, but if you already host it in Azure, so it's much simpler to you to use some existing solution for a platform that fit your requirements. But we will have a look. What if we want to host all of this locally or in our own servers? And let's move from the right side. So first we need to extract content for our knowledge base from XMCloud, OrderCloud, and Content Hub. Somehow to merge it and populate data source. Because there are not any tools to extract and merge information from OrderCloud, XMCloud, the Content Hub, we do it programmatically in .NET because all of the systems have SDKs and it's not so complex to do it programmatically. So next we need to choose a vector store that meet our requirements and populate it with information from data sources. To configure and manage virtual assistants, we need to choose some LLM orchestration tool that also meet our requirements and additionally will allow us to communicate with Sitecore products because not all of tools have ability to create your custom one or to extend existing one somehow. So just before start playing with different LLM orchestration tools, be sure that you are able to communicate with your Sitecore products. So next we will need to choose one of LLMs that based on, for example, performance and cost. And finally, sometimes we need to choose some analytical tools for tracing and monitoring all of our requests. To render all of this on the website, we will use Sitecore Personalize, and that's all. Looks a little bit complex, but it's not. So let's start with choosing of LLM. Here we can see best LLM for Retrieval-Augmented Generation with minimum hallucination index. So ChatGPT 4.1 mini was released about a week ago. I have already played with it. I can say that it's really cool. If compared with 4.0 mini, it has significantly improvements in hallucinations, in understanding agent instructions, and it's a little bit faster than 4.0 mini. So if you want best performing models, you can look at the Cloud Sonnet, but it costs money. And also sometimes you need an open source models. For example, you have a look at Qwen. This is China LLM. It was used for developing DeepSeek, and it was implemented initially for e-commerce systems, but it's not so good, frankly speaking, as a ChatGPT models. So next we need to choose some LLM orchestration flow where we will configure our virtual agents. And there are some criteria that we need to take into account. So first is a low code or programmatic. Next is open source, closed source. So if we need some license or not. Highlighted options, prototyping support, what I said before. So if we need to communicate with Sitecore products, we must be sure that it supports some prototyping, and we need easy to create our own nodes, our own tools, and connect our agents with Sitecore products. So next option is self-hosted versus cloud. So it depends on how our client wants to host it. Some of LLM orchestration tools are platform specific. For example, for Azure, for Google, for Amazon, you need to choose only platforms that supported Amazon, Google, and Azure. And if you need some self-hosted, you need to choose between self-hosted and scalability L price. One more information about low-code versus programmatic. For our use cases, for our client, we must have a low-code or no-code LLM orchestration tool because it will be one-time configured by developers, and in future it will be managed by content editors, by client sides that don't have any machine learning knowledges, just some marketers. So here you can see a comparison table of different low-code LLM orchestration tools. Flowwise and LangFlow are the best one for prototyping. I have a lot of experience with both. And you can use it if you need easily connect your LLM orchestration tool with Sitecore products. But LangFlow is mostly for developers, and it has complex UI. It supports prototyping in Python language. And frankly speaking, LangFlow is just a UI for virtual user interface for LangChain. Flowise is the simplest and is the best option that meet our requirements. So next criteria is choosing vector store. Criteria are about the same: open source, closed source, self-hosted or cloud, price, scalability. So the main highlighted option is hybrid search support, because the more control you have over choosing algorithms, configured different re-ranking, different types of algorithms like BM45, and so on and so on. It's much better because you can compare different techniques, different approach, and choose the best one for you. Also, some of vector stores support graph. It's like Neo4j, if you know what is it. It's like, for example, Facebook is stored in graph database, and graph database is just store relationships between objects. And of course, I hope you know what is it. And some of vector stores support graph, and sometimes if your entities have some dependencies and you store all of these entities in your vector store, it will be much easier to retrieve some dependencies without any additional queries. So here you can see a comparison table of different vector stores, and practically speaking, about all of them are the same, have the same features. We just choose VV8 because it's more flexible in configuration, it supports graph, and it has also some additional benefits that I will tell you right now. So this is one insight about VV8. VV8 Cloud was released a new personalization agent feature a week ago, and now you can store your user profiles and your user interactions directly into VV8 database. So in the similar way as you send interactions to Sitecore CDP, for example, you can do the same to telemetry to store your interactions in vector database. And you can receive personalization results out of the box if you store your user interactions. This VV8 personalization again is in technical preview right now, but anyway, I have already tested and can say that it's a very powerful feature. So next is criteria of choosing LLM engineering platform, our LLM orchestration tool. Also, we choose between open and closed sources, self-hosted or cloud, but very often our clients ask us about ability to track particular users, these user sessions, to have some user interface to find a particular user, analyze its session, etc. But not all of LLM engineering platforms support this feature, like trace users and sessions. And here you can see the comparison table of different LLM engineering platform, and the best one is LangFuse. Here we have experience with LangSmith, and frankly speaking, I mostly work with LangSmith, but LangSmith is a closed source, and it's only cloud. You are not able to self-host it. And as you can see, the whole architecture of our solution will be free of charge. And even if we want to move in future in cloud, it's will not so expensive for us. So this is what our solution diagram looked like before and how it looks like in the end. So this is a slide from my SUG. If you see, we have this LLM for Omini. It was the best LLM a month ago, but right now GPT 4.1 mini is better to use. And it's finally time for a demo. But before we start the demo, let me show you one more use case for virtual assistant in slides, because I'm not able to share you some live information from our production. So if you remember, we have an assistant that can analyze orders and make some store insights. We also have a similar assistant for insights, but for one particular order. When order manager open any order, he doesn't know anything about our user, but virtual assistants can fetch information about our user, for example, from Sitecore CDP, analyze it, and suggest some useful information like this. For example, virtual assistant sees that our user belongs to some segments in Sitecore CDP. It has some abandoned products and suggest including a sample of this product in order or remind some in follow-up communications. And this is how it works if we trace our request. So when the manager asks for order insights, we send a request to virtual assistant. Virtual assistant hit Sitecore CDP, analyze all of order session segments, and get some recommendations to the order manager based on this information about the user from CDP. No questions, sorry. And let's go to the demo. And let's start with the Flowwise. So Flowwise is LLM orchestration tool. You can just in drag and drop style create any assistance that you need. For example, for our use case, we have one single tool agent that has a list of instructions how to use and communicate with different Sitecore tools. Next, we connect our tool agent to one of the LLM of our choice. We use OpenAI, ChatGPT for Mini, because it's the best. So, but if you need any another model, you can easily add any one of your choice. So the same way, if you need to add any external tool, for example, if you need to use predefined Sitecore Sense, Sitecore Search, OrderCloud, CDP, etc., you can give my public repository that already has these tools and use it. It's a better way if your agent flow is configured by not developers. But the second option, if you're a developer and you configure it itself, you can just easily create any custom tool and configure just with a simple JavaScript. So you can hit any endpoint that you need to retrieve some information and use it as a tool. What about Flowwise? You can easily test your agent directly in this user interface. And as you can see, it works. Not so user-friendly with big images, but for testing is a good. So after you configure all of nodes, then you need to render it somehow on your website. So to do it, you just need to choose any options that fit your requirements. You can just inject it by simple JavaScript code. If you need some configuration for a window, you also have a lot of different styling and so on. You can use pure JavaScript to just request response. So you can share a chatbot. It's the same as you has on the QR code. Just to share your chatbot to your colleague, for example, to test it. So what we do, we want to render our chatbot by using Sitecore CDP. To do it, we just need to configure a styling, copy the script, and navigate to our Sitecore CDP and create web experience or web experiment. It's on your choice. For example, in our case, we have web experiment where we render our chatbot only for 10% of audience, just to track profit of using it, set some goals like order revenue, decreasing bounce rate, and so on. So to configure it, we just need to insert a simple script injection, our tag for rendering chatbot, and in JavaScript, we just copy paste information from the flowize. And that's all. Oops, sorry, guys. And that's all. And do you see my screen? I hope, yeah.
Yes.
Yeah. And as you can see, additionally, you can pass any parameters from your front end that you need. For example, we can bypass, but we can pass browser ID of Sitecore CDP. So this is how our rendered chatbot looks like. Let me try. Try to ask something. Do you have something similar to Miss your home? And as you can see, so it works. All links are hit our real website. Also, we can easily debug our chatbot. For example, let's provide it email address and it ask us about a send recommendation to the email. So yes, please. And something will go wrong now. As you can see, it has a small technical issue because my colleague will show another demo and it a little bit extend using of the same chatbot. But let's have a look to the analytical tools. As I said, we have a link views to this. We can navigate to our tracing and monitor all of the request responses. For example, I want to analyze why email is not sent to me. Okay, let's click to the send email feature. This is request. This error is about syntax. out another one request with correct syntax and reference that name is not provided. So my colleague add a required parameter name in the Sitecore send, and right now my request is corrupted, but our chatbot understand response that name is not provided and ask us about our name. And as you can see, email was successfully sent. We will wait a little bit and I will see you in my inbox. So what more I want to show you, it's a VV8 database, our vector store. So if you use VV8 Cloud, you have a good user interface where you can play with request to your model. You can switch between different algorithms, not only hybrid, but text. BM25 is a text search. You can search for neural text, neural vectors. Also, it has out of the box integration with LLMs, so you can directly ask a question and retrieve an answer. When we use hybrid, we can set a coefficient of hybrid. So I mean, if we, for example, have 0.7, it was 70% of vector search and 30% of text search. But we can, for example, set 90% of vector and 10 of text search. Also, we can easily see a score of calculating the results. We also, for example, the first one has score 0.9. We have also a score explanation with the formulas, how it works with hybrid search and blah, blah, blah. Yeah, we can, if we have a score, we can easily add a filter by score or a filter by some additional fields and so on. It even supports a filter by geo, by coordinates, like spatial search. And I can say that it's very powerful. And as you can see, it has beta agents for personalized agents. We will skip it for today's demo because it's not so easy. So next, let's show if we have some information. Yes, as you can see, I received 2 minutes ago email from our virtual assistant that use 30% out of the box with the same list of products that I asked. And even I have some discount. If I want to shopping, I can use this discount. So let's go back to the flow-wise. One more thing, what we can do here is go to the configuration. If we need understanding speech to text, like if you want to have ability to voice input, we can directly configure it here. For example, if you use OpenAI Whisper or some other tools, so we can easily do it here. Let me show you an example of virtual speaker. Suggest me something to wear to the night party. And as you can see, we can ask our virtual assistants to respond in JSON results because we have a predefined UI on front end to where we render the response. And as you can see, yes, he understands that grid performs to consider my night party with explanation why. If we go to the tracing of our requests, so it's not here. It's connected to another one, sorry. Okay, let's go back to the Flowise. One more thing here is chat feedbacks. If you enable chat feedback, you have ability to implicitly improve quality. Not improve the quality, you can implicit options to evaluate quality of your chatbot, for example. Yes, good, very nice, or awesome assistant, or so on. We can also easily set up course origin settings for analyzing and monitoring all of the requests. We can configure any of engineering platforms like Langfuse or Langsmith. Or just we need just provide some configuration credentials that we will find in corresponding software. For example, for Langfuse, we have also account where we can satisfy our keys, and that's all. All of your requests will be automatically traced here. One of the main feature is identifying users. So as you can see, we can only me. We can easily group all the traces by users, group every user by sessions, with duration, session durations, and so the request, and so on and so on. We can trace every single request and annotate it to compare, for example, different language models, different prompts, etc. It has evaluation with two options, human annotations or LLM as a judge. So we can manually look at every single request and mark it as for some different scoring, like an update, move in queue. For example, I have only one for demo, negative user feedbacks. Frankly speaking, it has a lot of some features that you can play with after analyzing, after manually analyzing of every request. You can, okay, it's good or bad. You can create different metrics that you need. For example, for the demo, I has only helpfulness and hallucinations. And when you complete it manually, so every single trace will be populated with some scores, and finally you can compare different models by different scores like hallucination, helpfulness, and so on and so on. And so I think that's all that I want to share with you. Let's go back to our slides. So thank you guys for your attention. Do you have any questions?
Yeah, Sergey, I think there is no much time left for any question. So is there a way like where we can approach you if we have any question?
Of course, you can reach me out in Any social, I have the same
Okay.
nickname, or yeah.
Mhm. Okay, great. So I think now we need to wrap up this call. So thank you all for joining us today. So we appreciate your participation and engagement in the Sitecore user group Jaipur. A special thanks to Sergey for sharing his valuable insight with us. Like it is truly impressive to see how you are actually using AI at this level. We hope everyone in this meeting found this session inspiring and informative. So looking forward to seeing you at our next gathering of Sitecore user group Jaipur. Yep. Thank you. Thank you all.
Yes,
Thank
thank you
you.
guys. Goodbye.
Mhm.